In the history of human beings, once we started learning how to count, probably that is the first step when we also started to understand the nature in a very scientific manner. Almost every civilization on the face of Earth and the history of time had their own ways and means of keeping count of things, having their own number systems. Many of them we understand and some of them we are yet to. All the number systems have one template in common, that is to keep count of things in the real world. But that is just one side of the coin. Now let's flip to the other side of the coin. When we simply call numbers whole or natural, the purpose is pretty clear and straight, and all of us have a very good understanding about it. But what about the negative numbers? Why do we need them? Many civilizations could not comprehend the purpose or even the meaning of a negative number. As far as the recorded history goes, only two civilizations, Bharat and China, have their contributions towards negative numbers well documented. And in this documentary, let us try and understand the origins of negative numbers and the contributions that came in from Bharat. I'm sure that you have a good understanding about the positional value system or the Hindu number system that we are using across the world. And for starters, here is a quick metaphor. Imagine that we have 5 men of different economic classes, sorted from poorest to the richest. And then we have a 2000 rupee note. Now this 2000 rupee note has a value in the market that it can buy certain amount of things. No matter who gives the 2000 rupee note, the worth of it remains exactly the same. And that is the absolute value. Now imagine that this 2000 rupee note is jumping across the pockets right from poorest to the richest. Then the value of this 2000 rupee note will reduce. What it means is a poor man having a 2000 rupee note, it is very valuable to him, but as it jumps the pockets towards the richest person, the value of this 2000 rupee note when it is in the pocket of a rich person is very less for him because he has a lot of money. This scenario metaphorically explains how the Hindu number system works, or the positional number system. A number has an absolute value which never changes, and also a positional value changes depending on which position it is occupying in a complete number. And if we try to transpose the 2000 rupee note scenario to the Hindu number system, this is how it works. 7 as a number has an absolute value that will never change, but 7 also has a positional value which will change as a function of its position that it occupies in a larger number. Before we try to understand negative numbers, let us try to understand what is a number in first place. Imagine we have 7 discrete objects to deal with. Those 7 discrete objects put together, the collection of it, is called as a number. Now when we try to represent this number on paper by writing it in one or the other language, that is called a numeral. No matter which language you write your numerals in, the number will always remain constant. The absolute value, that's what it is called as. The absolute value of the number will never change. The absolute value is a fixed attribute of a number, and then comes a variable attribute of the same number called as the positional value, and you know what it means. There are many civilizations which developed this positional value system, but it is Bharat who perfected it. So it is fair to say that Bharat only perfected the positional value system, but was not necessarily the first one to invent it. And there is a good reason why I am saying this, which you will understand eventually down the line. In addition to the absolute value and the positional value, there is a third attribute of the number which is called as directional value. And this attribute defines whether the magnitude of the number is a positive or a negative. You could have 7235 as a number, but the directional value, which attributes a positive sign or a negative sign to that number, significantly varies the value of that number. So if we go from bottom to top, absolute value is less significant, positional value is more significant than absolute value, and directional value is even more significant than the positional value. Now what sets Bharat apart in its contributions in the field of mathematics is, number 1, it perfected the positional value system, and number 2, Bharat very well comprehended this directional value system, how to deal with positive and negative quantities, and including 0, all the arithmetic operations with your integers is very well perfected in Bharat. And that story of directional value, especially dealing with negative numbers, that is one of the greatest historical contributions that came in from Bharat. But unfortunately, many of us are not aware of it, and this doc film is all about just that. So before we move forward, a quick side note. The absolute value, positional value and directional value, all three attributes define what a number is. But do we understand a number completely, or could there be another thing like dimensional value? That means as you transpose up into different dimensions, will there be any other attribute which we can call just like a dimensional value that would further deepen our understanding about numbers? Let me know your thoughts in the comments below. I would like to read them. Owing to the subject of this doc film, the origins of negative numbers, the most important source that we have is Brahmasputa Siddhantam, written by Brahmagupta in the 7th century CE. This work on mathematics and astronomy is one of the crown jewels in the history of science that was developed in Bharat. Brahmagupta, who is a great astronomer and mathematician, in this book called Brahmasputa Siddhantam, he elaborated a diverse set of subjects related to mathematics. Definition of positive numbers and negative numbers, including zero, and how to perform arithmetic operations with all three, principles of algebra, dealing with indeterminate equations, principles of geometry, trigonometry, and the list is very long. In this doc film, our main interest is purely about the integers, the positive numbers, zero, and the negative numbers as defined by Brahmagupta. Cutting across straight to the crux of the topic. In the 18th chapter of Brahmasputa Siddhantam, Brahmagupta codified the rules for the arithmetic operations with positive numbers, zero and negative numbers. How to add them, how to subtract them, how to multiply and divide them. And what you're seeing on your screen are just that. A well codified set of Sanskritam slokas in which Brahmagupta codified the arithmetic operations of positive numbers, zero and negative numbers. Now let us try to break it down and understand. Across the set of slokas, Brahmagupta repeatedly uses three shabdas or three words. Dhanam, which essentially represents the positive quantity, Shunyam, which represents zero, and Runam, which represents the negative quantity. I color coded all these three words, Dhanam in red, Shunyam in green, and Runam in blue across the slokas. Just a simple glance will give us a feeling like how tongue-twisting these slokas are. But all these slokas, when translated into a language that we can understand, this is how it looks like. A long list of the principles of arithmetic operations on how to deal with positive quantities, zero and negative quantities. Now let us deep dive into this. If we want to understand the rules on the arithmetic operations codified by Brahmagupta, we need to have a clear-cut understanding, rather an in-depth understanding about three words, Dhanam, Shunyam and Runam, because fundamentally Sanskritam is not a simple language to deal with. The depth of the language is just uncomprehendable. So these three words, the real meaning of it, has an incredibly important role to play in these rules of arithmetic operations. So starting with the first word, Dhanam. Dhanam in Sanskritam, what it means is wealth, accumulation or credit, and in that connotation, this word Dhanam would be used. For example, we have this word called Pravardhamana, which means progression and development. And the word Pravardhamana is built on this root word Dhanam. Moving next to Shunyam. This is pretty clear and straight for all of us. Shunyam means something that is void, emptiness, and also a stable state. In those connotations, this word Shunyam in Sanskritam would be used. And moving to the third one, Rinam. This is very interesting. The word Rinam means to return or obligatory or debt. In such connotations, this word Rinam would be used. In fact, in Sanskritam, this root word Ru means to give back, that you owe something to someone or to return back. And exactly the Latin word for same connotation is also re. That is the reason we have refund, return, redeem, repent, retrospect. All these English words originate from the Latin root word re. And all these words interestingly represent, which has something to deal with the past, starts with the word re. So in this context, the Latin word re and Sanskritam re has exactly the same meaning. So that is runam. So I will leave this here. But if you really want to understand in detail about Brahmagupta's rules on arithmetic operations, it is very important that we go much more deeper in understanding the Sanskritam words dhanam, shunyam and runam. Now here comes the most thought-provoking part on understanding positive and negative numbers. According to the codification done by Brahmagupta, shunyam or zero is a stable state, and both dhanam and runam are transient states that will go up and down, but never below shunyam. Now this understanding is in stark contrast with our understanding of negative numbers, where today we perceive that -2, -3, -4, so on are the numbers which are less than 0. This is where Brahmagupta's explanation about a positive and negative quantities opens up totally a new different direction of thinking on understanding numbers. I repeat, according to Brahmagupta's codification, the positive numbers, which is called as dhanam, and the negative numbers, which is runam, are transient states with regards to 0, and 0 is the ultimate stable state. So for you to think much deeper into this topic, I just left a couple of notes here. The first thing is Brahmagupta's illustration of positives and negatives is different and challenges modern day understanding of negatives and positives. So towards the right, what you see here, the number line. Today we understand that -1, -2, -3 lies towards the left hand side of 0, which essentially means that the value is less than 0. And +1, +2, +3 is towards the right, which means it is greater than 0. But Brahmagupta's codification states that a 0 could start anywhere, but a positive essentially represents forward movement and a negative represents a backward movement, all with regards to the position of reference that you choose. And second thing is, according to Brahmagupta's illustration, positives and negatives are not just magnitudes greater or lesser than 0, but they are transient magnitudes with reference to 0. This is very crucial to understand. And in this concept of Brahmagupta, there is no value, absolutely there is no value which is lesser than shunyam. Shunyam is the ultimate stable state. It really feels good when a 1500 years old mathematical text challenges the status quo that you and me have been learning since our school days. It is not about who is right, it's all about what is right. And a quick touch and go, the rules on additions of positives, negatives and 0, as the first one reads, Dhanayor dhanam runam runayoh, which means positive plus positive gives a positive, negative plus negative gives a negative. If I literally have to spell what Brahmagupta wrote, dhanam plus dhanam gives out dhanam, runam plus runam gives out runam. Also to highlight the fourth principle, shunyoh shunyam, 0 plus 0 is equal to 0, or shunyam plus shunyam is equal to shunyam. Now this is very important. In the history of mathematics, Brahmasputa Siddhanta is the oldest known mathematical scripture which codified the rules on arithmetic operations with 0. Up next we have the rules on subtracting positives, negatives and 0. For instance, the first one reads, Unmadhika dvishodhyam dhanam. It means a larger positive minus smaller positive results in positive. Same way, another example, for instance, the third one, Shunya vihinam runam runam dhanam dhanam. It means when you subtract 0 from a positive or a negative quantity, you will be just left with the same positive or negative quantity. Up next we have the rules on multiplication. For instance, if you see the second one, dhanam runayoh, which means negative multiplied by negative results in positive. The immediate next one, dhanavadau dhanam bhavati, positive multiplied by positive results in positive, and so on. And lastly, we have the rules on division of positives, negatives and 0. As you can read the first one, dhana bhaktam dhanam. When you divide a positive by positive, the result is positive. Take a look at the last one. Kham khabaktam kham, which means a 0 divided by 0 is equal to 0. We know that anything divided by 0 is undefined, so let's park that argument for a second and let's try and understand the literary sense of this. Why did Brahmagupta mention it as kham khabaktam kham and not shunyam shunyabhaktam shunyam? Till now we understood that shunyam means 0, and that's how he articulated in rest all slokas in many places. But why kham is also representing 0? This is very important to understand. Hold this and we'll come back. Now, owing to the subject of this doc film, the origins of negative numbers. So a simple question that we should ask ourselves is Brahmagupta the first one who constituted this idea of negative numbers, or how to deal with this element of subtraction? Subtraction of numbers is where we encounter the negative numbers. It's pretty obvious, right? So let us do a bit of time traveling 450 years before Brahmagupta. So that's around 200 to 250 CE. That is when this manuscript called the Bakhshali Manuscript was written. As far as Bharatiya Ganitam or the ancient Indian mathematics is concerned, this is the oldest manuscript, which is almost 1800 years old. Is the oldest one that's available to us as of today. And this is where another story related to the negative numbers would start. I already made a very detailed documentary about Bakhshali Manuscript. It's in the channel, or I'll leave the link in the description below should you wish to watch it. So getting back to the current context, negative numbers and subtraction. What does Bakhshali Manuscript tell us about these two aspects? First of all, the writing style or the script. In Bharat, well over thousands of years, we have this culture and tradition of naming the script of Sanskritam after the name of Saraswati Devi. So the oldest known script about Sanskritam is Brahmi, and from Brahmi came Sharada, and from Sharada came Siddhamatrika, and from there we have Devanagari, which we are currently using today. And this manuscript, the Bakhshali manuscript, is written in Sharada script. What you're seeing here on the screen is one of the oldest written forms of Sanskritam, written in Sharada script. And here towards the left, in the white box, I gave how the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0, all the 10 digits, are written in Sharada script throughout this manuscript. Take a look at this part of the manuscript that I highlighted. It is two different arithmetic operations, 3 plus 3 and 8 plus 8. It's quite interesting to observe these arithmetic operations from a different standpoint. Let us ask a question. Why and how the arithmetic symbols that we are using today came into existence? With this question and this piece of the manuscript that we have on the screen, 3 plus 3, one written on top of the other one, and 8 plus 8. What does it mean? And how did this plus symbol came into existence? Let us try to find it out. Like I already mentioned a couple of minutes ago, the Bakhshali manuscript is written in Sharada writing style or Sharada script, which originated from its predecessor, the Brahmi script of Sanskritam. So to understand this 3 plus 3 or 8 plus 8 from the Bakhshali manuscript, the best available source for us to rely on is the Pillars of Ashoka, the Edicts of Ashoka, which date back to 3rd century BCE and is written in Brahmi. And if we see on these edicts, you have something like a plus symbol where I pointed with these white triangles, and there is a bit of zoom as well towards the right. So there is something like this plus symbol. We don't know what exactly it means yet, but definitely in Bakhshali manuscript there is a plus sign, and in the Edicts of Ashoka there is also a plus sign, and both essentially are very related writing styles. The Pillars of Ashoka are in Brahmi and the Bakhshali manuscript is in Sharada. Brahmi gave birth to Sharada script. So let's try and understand what is the meaning of this plus symbol. Luckily, the Brahmi script is well decoded and we can figure out very easily that This plus symbol, which is on the edicts of Ashoka, is actually a Sanskritam Shabda which represents Ka. So the 3 plus 3, it's not a plus sign, but it is a Sanskritam Shabda which is written in Brahmi, and it should be pronounced as 3 Ka 3. The plus is nothing but Ka. In fact, you can try it out, the Unicode for Brahmi Ka. It is U plus 11013. Try out this Unicode in your laptop and you will be able to type the Brahmi letter Ka, which exactly looks like plus. But what is the meaning of Ka? What is the meaning of 3 Ka 3 as written in Bakhshali Manuscript? That is most important for us to understand. Let's move forward. So finally the cat is out of the bag, and here is the meaning of 3 Ka 3. The word Ka or the Shabda Ka in Sanskritam means diminish or reduce. So going top down, step by step, superficially what appears to be like 3 plus 3 should be pronounced as 3 Ka 3, and the word Ka or the meaning of the Shabda Ka means diminished. So 3 diminished by 3, essentially 3 minus 3. So basically it is not 3 plus 3 in modern parlance, but is actually 3 minus 3 in Sharada script. And here is a snippet of the meaning of this Shabda Ka from a Sanskritam dictionary. So it is not a symbol, but a Sanskritam letter. What is even more important to note here is, generally in any language, a group of letters form a word and the word has a meaning. But in Sanskritam, single letter, individual letters can also hold meaning. For instance, here Ka means to reduce. And until and unless one understands what is the in-depth meaning of Sanskritam letters, one will not be able to decode what's actually written in the scriptures. So anyways, coming back to this topic. So from Bakhshali Manuscript, it is very clear and evident that subtraction as an operation existed in Bakhshali Manuscript. But did negative numbers also exist in Bakhshali Manuscript? In my research, I could not find that yet because we don't have access to the complete Bakhshali Manuscript. But we cannot rule out the possibility of existence of negative numbers or the usage of negative numbers, because clearly subtraction as an operation existed in Bakhshali Manuscript. Let me play a bit of devil's advocate. Am I cooking up all this, or what is the truth? If anyone gets this doubt, the first thing that he or she should know is, or at least try to do, is learn about Bakhshali Manuscript for yourself, and then you will be able to understand the truth for yourself. Now if we take a quick look back into the rules of division codified by Brahmagupta, Kham Khabaktam Kham, which means 0 divided by 0 is equal to 0. So we asked that question, why did he use Kha instead of Shunya? Because in Sanskritam, like I said, discrete letters, single letters also hold meanings, very specific meanings. Ka means diminish, same way Kha represents sky. Hope you can find the difference between the sounds. The first one is Ka, which means diminished, and Kha means sky. So here Brahmagupta is saying that sky divided by sky is equal to sky. So basically it means that a void divided by void is equal to void. So this is just to give you a picture of how cryptic the language of Sanskritam could be. Now if we just keep looking only for the Shabda Shunya, then one will not be able to understand what is this Kham Khabaktam Kham. It means void divided by void is equal to void. And here in this context, sky is being represented as void. That's how cryptic it is. So again, owing to the objective of this doc film, the origins of negative numbers, we started with Brahmagupta, where he clearly codified the rules of how to deal with negatives and positives and zero. But was Brahmagupta the first one to do that? Not necessarily, because Bakhshali Manuscript also quote the operation of subtraction, and as a benefit of doubt, maybe that negative numbers also existed in Bakhshali Manuscript, which belongs to around 230 CE. But is Bakhshali Manuscript the oldest source of subtraction and by extension negative numbers? Not necessarily. Let us go further back into time, and then we have one of the world's oldest scripture on astronomy, Surya Siddhantam. Till today, there is no proper dating attributed to Surya Siddhantam, and there are varied opinions of 1000 BC, 1500 BC, 3000 BC, some date it in AD. So it's whatever be the case, it is the oldest treatise on astronomy that is available to the humankind at this point in time. And this, what you're seeing on your screen, is an example of how Surya Siddhantam conceives the foundation for the concept of negative numbers. Here we go. The fifth slokam from the second chapter of Surya Siddhantam says that when a planet is pulled strongly in their Uchchasthanam apices, the planet's orbital velocity will be increased, and this is called as dhanam, and when they move farther, their orbital velocity will be decreased, and this is called as runam. Dhanam and runam. Remember these words? These are the exact words used by Brahmagupta in his codification of positives and negatives. So anyways, coming back to this one. This particular slokam is the beginning of orbital velocity calculations of different planets in their orbits. And dhanam is referred to as increase in the orbital velocity when it comes closer to the object around which any given planetary body is revolving. So the highest orbital velocity will be achieved when it is closest to the object that it is pulling, like I showed here in the diagram towards the right. And the lowest orbital velocity will be there when it is the farthest from the object that it is making it to revolve in that orbit. So whenever the planet increases its orbital velocity, that increase is called as dhanam, and whenever the planet loses its orbital velocity, it is called as runam. Now this definition exactly matches with the codification done by Brahmagupta. Like I said, dhanam and runam, positive and negative, are shown as an increase and decrease with reference to a stable state, which is shunyam. So Brahmagupta and Surya Siddhantam are perfectly in line. And what's also important to note is Surya Siddhantam came much before than Brahmagupta. Again, it's not about who is first, it's just a quest to know what are the origins of these negative numbers. So if we sum up all the sources, the negative numbers, the origins of it, we can find in Brahmagupta's Brahmasputa Siddhantam, and then parts of it in Bakhshali Manuscript, and most importantly, the foundations of Brahmagupta's work could be found in a text which is much before than Brahmagupta, the Surya Siddhantam, which talks about the dhanam and runam concepts, and also gives formulas to calculate the orbital velocities of planets. And there is a very widespread usage of sine function in those calculations from Surya Siddhantam, which eventually leads to handling negative quantities. So coming back to the subject, what are the origins of negative numbers? I don't know, because it is much deeper than what we could even possibly imagine. Saying that Brahmagupta was the first one to constitute the idea of positives and negatives would be a factually incorrect statement. Rather, what's correct is Brahmasputa Siddhantam, written by Brahmagupta, gives us a clear-cut guidelines on how to deal with these arithmetic operations of positives, negatives and zeros. Also, ancient China contributed to the idea of negative numbers, and their arithmetic operations are also well codified. But when we really want to understand the origins of negative numbers, if Chinese mathematics on dealing with negative numbers predates Surya Siddhantam, then it is a factually right statement to say that the concept of negative numbers was first pioneered by China. But if Surya Siddhantam predates Chinese mathematics on negative numbers, then Surya Siddhantam stays as the origins or the very genesis of this concept of negative numbers. Another very important thing is, it's very interesting to see how Europe dealt with negative numbers. It is quite surprising, astonishing and amazing that negative numbers are perceived as evil, taboo and satanic and whatnot until last 200 years ago. That was the perception in Europe about negative numbers. While in Bharat and China, both the civilizations pioneered dealing with negative numbers. The history of mathematics or the history of science, what we read today, is absolute crap. Absolute crap. The Asian civilizations are totally ignored, their contributions are totally ignored in many fields, and negative number stands as an undisputable scenario where the contributions which came in from Bharat and China were not known to the world. At least the majority of them don't know it. And if you start speaking about negative numbers, that exposes how hypocritic Europe has been. Let me quote a simple example and you will understand better. Remember the laws of planetary motions defined by John Kepler, which we might have studied during our school days? Here is the first law of John Kepler on laws of planetary motion. The orbit of a planet is an ellipse with the sun at one of its foci. So basically here, the first law of planetary motion defines that all the orbits of planets are elliptical, and this is revered as the first discovery that the orbits of planets are elliptical and not circular by the Western historians. Before I move any further, let me clarify one point. Absolutely no disregard or disrespect towards John Kepler and his findings. That's not my intention. In fact, I want to expose the disregard and disrespect shown by Western historians towards the real history. So why would I disrespect John Kepler in first place? I want to expose such kind of hypocrisy. And here is it. You check any ancient Bharatiya scriptures on astronomy like Surya Siddhantam, Aryabhatiya, Brahmasputa Siddhantam. Everywhere the planet's orbit is defined as an ellipse. Elliptical orbits are very common. In fact, the very sloka that we just saw for Dhanam and Runam clearly defines that the orbit of a planet is elliptical. Thousands of years before John Kepler did, but nowhere that we would learn about these facts in any of our school. All we still learn is that John Kepler first discovered that planets revolve in elliptical orbits. Again, I repeat. No disrespect towards John Kepler, all I want to expose is the hypocrisy that's staring into our face. So use your common sense and go beyond your textbooks and read the real history in an unbiased format, and then you will get to know what is the truth. So that is a very brief history about the origins of negative numbers. And this is the third episode of the Bharatiya Ganitam web series from Project Shivoham. I get a lot of emails and DMs where people are saying that Bharatiya Ganitam, they are really liking this web series. Thank you so much for your compliments. But I would be more happy if you not just watch these videos, but get to the actual scriptures, read for yourself and spread the truth so that every student in Bharat and across the world gets to know the real contributions that came in from Bharat in the field of mathematics. We'll be coming up with more episodes of Bharatiya Ganitam. But for now, and as always, thanks for watching.